Hi, everybody. Today we're going to be talking about inverse relations and functions. And what I want you to do is when you hear the word inverse, think of the word reverse. So the inverse is the reverse. And we have up first the definition of an inverse relation. If AB is an ordered pair of a relation, then BA is the inverse. So you're switching the coordinates to get to the inverse. It says find the inverse of the relation S. So all we're going to do then is just switch the X and the Y. So we're going to put the Y values with X and the X values with Y. There's our X values, right? Now they become our Y values. Here's the Y values. Now they become our X values. So if you have the coordinates for the graph of a relation and you want to graph the inverse, just switch the X and the Y and graph that. All right, so let's demonstrate that. So first we're going to graph relation S, and we'll do that in red. And then we're going to graph the inverse of relation S. I'll do that in blue. All right, and if you've graphed the inverse correctly, the inverse will always reflect over the line y equals x. So let's draw the line y equals x. And you see how perfectly our inverse reflected over that line. This is the line y equals x. All right, so I answered my own question already here. What do you notice about the graphs of S and its inverse? The graph of the inverse of a relation is a reflection in the line y equals x. Sometimes people say in the line, some people say over the line, some people say about the line. They all mean the same thing. All right, let's keep going. Sketch the inverse of the function. All right, so the first thing I want to do is, for me, it's easiest to make a quick table of values. I'm going to list out all the points that I see for the original function. Now I'm going to make another table of values where I just flip those points. So I'm going to put the y values in for x and the x values in for y. And now I'll graph those points. If I did this correctly, my inverse will reflect perfectly over the line y equals x. And it looks like I did because there's a nice reflection over that line. All right, next question here are the following inverses. So all we really want to do is look at each graph, draw in the line y equals x if it isn't already there, all right, and then decide whether or not we have inverses. So I'm just going to quickly draw in the line y equals x on all these graphs. All right, and you want to take a minute, pause the video, and decide for yourself which ones are showing inverses. All right, so this first graph, absolutely yes. This second graph, absolutely no. It's not reflecting over the line y equals x. This would be a yes. And this one would also be a yes. it says if the relation or function is described by an equation in x and y, you can switch x and y and then solve for y to get the inverse. All right, so this time we don't have coordinates, we have an equation, and we need to find the inverse. So remember, inverse is the reverse. So we want to switch the x and y in the equation. That's the first thing we're going to do. So instead of y there, we're going to put an x, and then we're going to replace the x with the y. So you're going to reverse these. Now, we want to have our equation in terms of y, so we'll add 10 to both sides. And then we're going to divide by 3. And that is our inverse equation. Now it says graph the function and the inverse. Well, you know, this equation that we have here for the inverse doesn't look so fun to come up with coordinates for. So I'm going to come up with some coordinates for my original function, y equals 3x minus 10, and then I'll just use those coordinates and reverse them for my inverse. So I'll show you what I mean. 0, 1, and 2. I only really need like 3 points, and those are nice and easy. All right, when I put those x values in, I'm going to get negative 10, negative 7, negative 4. And then I'm going to reverse those for my inverse. And now I can graph that. Now this is the line, right? Y equals 3x minus 10. So I want to make sure we don't just connect 3 points. We want to extend it. And now I'll graph my inverse. And then to help me decide what I'm dealing with here, I'm going to add in my line y equals x. So it says graph the function and the inverse. Is the inverse a function? Now remember, an easy way to determine if we have a function is if we drop a vertical line. If it only hits in one place anywhere on the function, we know anywhere on the inverse, we know that it's a function. So we can see by looking at this, right, this red line that we've created, that anywhere we were to drop a vertical line, we would only hit that in one place. So this inverse is a function. All right, let's go ahead and try the next one. Find the inverse of y equals x squared plus 3, graph it, and its inverse. And is y equals x squared plus 3 a function? Is the inverse a function? All right, so we have a lot to do here. We're also going to graph the inverse. Now, if you're not really sure what the graph should look like, you would want to put this in your calculator to know, to make sure that you're picking points that are really going to accurately represent your equation here. The values I'm going to pick are negative 2, 0, and 2. All right, and that looks good to me. We know we have a parabola and it's moved up 3. All right, now we're going to graph our inverse. I always like to add in my line y equals x. All right, so it says, is y equals x squared plus 3 a function? Well, if we drop a vertical line anywhere, we only hit it once, so this is a function. Looking at the inverse, if we drop a vertical line, we're going to hit it in more than one place. So the inverse is not a function. Now, an inverse function is often denoted by this notation right here. That is read f inverse of x. So you'll see it raised to a -1 power. You then to find the inverse of the function, right? So how do we find the inverse of the function algebraically, just like we did above, right? We're going to switch the x and the y, and then we're going to solve for y. Now, sometimes when we have a function, we use f of x, but remember that this can be rewritten, and this one can be rewritten. And now we know all we have to do is switch or reverse, right, the x and the y. So let's go ahead and do that. So we've got x equals 2y minus 1, solve for y. For this guy, we're going to end up with x equals y cubed plus 2. And remember, if we want to undo a cube, just like if we want to undo a square, we take the square root. If we want to undo a cube, we're going to take the cube root of both sides. And that would leave us with the cube root of x minus 2 equals y. All right. Now, there's one more note here, composition of inverse functions. It's a little, it looks a little crazy. Look at that and think we cannot, you have no idea what I'm talking about here. All this is saying is that if you take an inverse and you put it into the original function, you're going to get a value of x. If you take the original function and you input it into the inverse, you're going to get a value of x. Now, this is going to come into play in calculus. Right now, it probably seems a little useless, all right? But this will come into play later and will be important. So I just wanted to expose you to it, but I don't want to spend too much time on it. So first of all, to prove what I'm saying here, I give you a function, right? I give you this function, f of x equals x plus 1, or y equals x plus 1. And I want to write the inverse. So that means I'm going to switch the x and the y, right? So I'm going to get x equals y plus 1. So x minus 1 equals y. So it says find f inverse of f of x. So this is saying in the inverse function, which in our case, right, is right here, x minus 1, we're going to replace x with f of x. So let's do that. F of x we know is x plus 1. So we're going to replace x with x plus 1. Minus 1. And what do we end up when we do that? Well, we end up with x plus 1 minus 1 is x. We're happy about that. Proves my point there. All right, let's try it again, but this time let's do f And we're going to put the inverse in this time, just to have a little fun. Now, the f function is x plus 1. Right? That's the f function. And we're going to input the inverse. Well, what was the inverse? X minus 1. So we're going to replace the x value with x minus 1. So we're going to get x minus 1 plus 1, and that equals x. All right? But guess what? You really don't have to do any work if you can remember that this always works. Whenever I put the original function into the inverse, I get x. Whenever I put the inverse into the original function, I get x. So for number 8, there really isn't any work, and that's why we love to know this rule. The answer is equals x. Done. Love it. All right, now lastly, there's one other way to find an inverse, and that would be using your graphing calculator. The calculator can only draw an inverse. It cannot give you the inverse of a particular function. So we're going to practice it, and we are going to practice it using the function y equals x squared. So you'd enter the function into y, you'd go to the graph, then we're going to do the steps that I have listed there. You can either watch me do it on the calculator, or you can follow the steps that are in your notes, and we'll just see how it comes up with our inverse function. Right, so I've entered my function into y equals. I'm going to go to the graph. All right, I'm going to go to second draw. So that would be the program button. It's highlighted in red. And you'll see that option number 8 is draw inverse. So you can either press 8 or you can go down to 8 and hit enter. All right, and we're going to tell it what inverse I want to draw. So I have to tell it what function I want. All right, so I'm going to go to vars, y vars, enter, enter. So I want it to draw the inverse for the function I put in y1 and hit enter. And there you go. It's drawn the inverse. Okay, so it only draws the inverse. It doesn't actually give you the value of the equation. All right, so just to recap here, methods of finding the inverse of a function. Ordered pairs, you're going to interchange the x and the y coordinates. For a graph, you're going to reflect over the line y equals x. And if you're going to do it algebraically, you switch y and x and you solve for y. All right, that's everything I have in this lesson. Thanks for watching.